Hey there, deep divers. Are you ready for another deep dive? Today we're going behind the scenes of AI image generation to explore the technical magic that makes it all happen.
It really is pretty magical.
Yeah, and we've all seen the amazing things that AI can do now.
Right.
From ChatGPT, crafting text to stable diffusion, conjuring up these amazing images, but
Yeah.
under the hood it gets really complex.
Oh, yeah, it's very complex.
So today we're tackling a research paper with a very complex title.
Okay.
It's called Improved Training Technique for Latent Consistency Models.
Catchy.
Yeah, super catchy. But trust me, it's fascinating and super relevant to where this whole field is going.
It really is.
So to understand why this paper is so important, we need to talk a little bit about the current state of the art.
Okay.
So right now, the big players in AI image generation are diffusion models.
Yep.
They produce incredible high-quality images,
They do.
but they're really slow.
Yes. They are notoriously slow.
Thousands of steps to create one image.
Yeah, you have to think about it like
Oh my God.
it's like waiting for paint to dry
I know.
for every single brushstroke.
Yeah.
So not exactly ideal if you're looking for speed and efficiency,
Right.
which everyone is.
Okay, so that's where these consistency models come in.
Yeah.
They're the hot new thing,
Yes.
promising to be way faster than diffusion models.
Potentially.
Yeah?
But
Yeah.
they haven't quite lived up to their full potential.
Yeah.
Especially when it comes to working with latent space.
Right.
Okay, so latent space.
Yeah.
I always imagine it like squeezing a giant encyclopedia into a tiny little box.
Okay.
All the information is there,
Yeah.
but it's just in a different form.
Yeah, you can think of it like a compressed version of the data.
Yeah.
And that's exactly how most advanced AI models work.
Oh, wow.
They work on this compressed version of the data.
Interesting.
It is efficient,
Okay.
but it comes with challenges.
Like what? What kind of challenge?
Well, the encyclopedia gets a bit jumbled up in that tiny box.
You could say that
Okay.
this paper found that latent space is full of what they call impulsive outliers.
Yep.
So basically extreme values in the data.
Mm-hmm.
So imagine you're trying to bake a cake and the recipe calls for, 1 cup of flour,
Okay.
but then randomly throws in 50 gallons of milk.
Oh my gosh.
Yeah, it's going to throw everything off.
That's a recipe for disaster.
Exactly.
No wonder consistency models have been struggling in latent space.
Right.
So this paper, did they finally crack the code? What did they do differently?
They did, and the key was getting creative and tackling those outliers head on.
Okay.
Previous attempts to fix this relied on something called pseudo-Huber loss,
Okay.
which worked okay for normal images,
Hmm.
but not for the wild west of latent space.
Okay.
But this paper introduced something called Cauchy loss.
Cauchy loss.
Yes, Cauchy loss, which is much better at handling those crazy outliers.
So instead of freaking out over the 50 gallons of milk,
Right.
they found a way to adjust the recipe, so to speak.
Yeah. They essentially found a way to account for those outliers without letting them dominate the model's learning process.
Okay.
It doesn't completely ignore them, but it doesn't overreact to them either.
Very clever. So they tamed the wild outliers of latent space,
They did.
paving the way for consistency models to really shine.
Yes.
That sounds like a major breakthrough.
It is.
So what else did they do to boost these models?
Well, on top of Cauchy loss, they had a few other tricks up their sleeve.
Okay.
One really interesting technique they used was incorporating diffusion loss, but only at the very beginning of the model's training.
Okay, now why only at the beginning? I would think you would want that throughout the whole process.
It's a bit like learning to bake.
Okay.
You wouldn't start with a complex, wedding cake.
No.
You'd start with something simple, like a basic vanilla cake,
Right.
after the fundamentals.
Okay, so they're easing the model into things.
Exactly.
So it gets a good grasp on the basics before things get too messy. Okay, what other techniques did they use? Was it just a matter of throwing everything at the wall and seeing what stuck?
Not quite.
Okay.
They were very strategic.
Hmm.
They actually did a lot of testing to see what worked best.
Okay.
They also used a technique called OT matching.
OT matching.
OT matching to reduce randomness in the training process.
Okay, so they were trying to bring some order to the chaos of latent space.
Exactly.
Okay, anything else?
They also tweaked the model's internal gears
Okay.
with techniques like adaptive scaling
Okay.
and a modified layer norm.
So it's all about optimizing the model's performance.
Yeah, squeezing every ounce of potential out of it.
Okay, so they tackled those pesky outliers,
Yes.
added a dash of diffusion magic early on,
Right.
brought some order to the chaos with OT matching,
Yes.
and fine-tuned the model's inner workings.
They did.
But the real question is, did it actually work? Did all this effort lead to better results?
That's what we'll dig into next. They tested their souped-up consistency model on some standard image data sets,
Yeah.
and the results were impressive.
All right, hold on. I'm dying to know the details. We've got to unpack those results. But first, a quick break. We'll be back in a flash.
We're back and ready to dive into those results.
Okay, let's do it.
So remember how we talked about diffusion models being the gold standard,
Yeah.
but super
Yeah.
slow?
Yeah.
Well, get this new consistency model could generate images in just 1 or 2 steps.
Whoa, that's insanely fast.
It is.
We're talking like a fraction of the time compared to diffusion models.
Yeah.
But speed isn't everything, right?
Right.
What about the quality of the images? Did
Yeah.
they sacrifice quality for speed?
That's the best part.
Oh,
While the quality isn't quite on par with the absolute best diffusion models yet,
okay.
it's a huge GE leap forward for consistency models.
So no more blurry messes.
Exactly.
Those older consistency models, the images they generated sometimes look like they were pulled through a blender.
Yeah. And if you look at figures 5 and 6 in the paper, you can really see the difference.
Yeah, I'm looking at those figures now.
Yeah.
And they're really impressive.
It's night and day.
Okay, but let's get back to the how for a second. I'm still a little curious about this Cauchy loss.
Yeah.
What makes it so good at handling those outliers? Can you just break it down a little further?
Sure. Think of it like this. Imagine you're trying to measure the average height of everyone in a room. Okay. Now throw in a basketball player who's 7 feet tall.
Okay.
That one outlier could skew your average significantly, right?
Yeah, one extreme value can really throw things off.
Exactly. Cauchy loss is like a special kind of measuring tape
Interesting.
that's less sensitive to those extremes.
Okay.
It doesn't completely ignore the basketball player, but it doesn't let their height dominate the calculation either.
So it's like finding that balance, allowing the model to learn from the overall data without getting sidetracked by those outliers? That's
Correct.
really clever.
It is, and it's crucial for working with latent space where these extreme values can really wreak havoc on traditional methods.
Okay, I'm starting to get a real appreciation for the ingenuity behind this research.
Yeah.
So we talked about Cauchy loss, but what about those other techniques they used?
Yeah.
You mentioned diffusion loss at the beginning. Can you expand on why that's so important?
It's all about giving the model a solid foundation to build upon.
Okay.
So remember our baking analogy?
Yes.
Applying diffusion loss at the early stages when the noise levels are very low is like letting the model master a simple recipe before moving on to a more complex one.
So it gets a good grasp on the basics before things get too messy. What about
Certainly.
OT matching?
So OT matching,
Mm-hmm.
it involves strategically pairing up the input data with the noise that's added during training.
Oh.
It's like finding the best possible matches between puzzle pieces,
Oh, okay.
ensuring that each piece contributes to the overall picture.
So less random connections, more intentional pairings.
Exactly.
That's really cool.
It is.
And what about those fine-tuning techniques? Adaptive scaling and the modified layer norm.
Yeah, so adaptive scaling helps the model adjust its sensitivity to those outliers as it learns,
Okay.
preventing it from overreacting at any point.
So it's like a built-in safety mechanism, making sure the model doesn't get thrown off course.
Exactly. And the modified layer norm helps ensure that the data flowing through the model is properly normalized.
Okay.
So like cleaning up the data and making it easier for the model to learn from.
It's like they've thought of everything,
They have.
optimizing every step of the process, but, all this technical detail, sometimes it's easy to lose sight of the bigger picture.
Right.
What does all this mean for the average person?
Yeah.
Why should they care about this research?
Well, it's not just about fancy algorithms and technical jargon.
Right.
This research has the potential to truly revolutionize how we create and interact with images.
Okay.
Imagine a world where anyone can generate stunning visuals with just a few clicks.
Wow, that would be incredible.
No need for expensive software or specialized skills.
It's like putting the power of AI image generation into everyone's hands.
Yeah, democratizing creativity.
I love it.
Exactly. And it goes beyond just creating cool pictures for social media.
Right.
Think about the impact on fields like graphic design architecture, even scientific research.
Wow. Yeah.
Imagine being able to generate complex 3D models of molecules or design prototypes for new inventions in a fraction of the time it takes now.
Oh my gosh, the possibilities are truly mind-boggling.
They are.
This research could spark a whole new wave of innovation across countless industries.
It really could. And while this paper focuses on images, the techniques they've developed could potentially be applied to other types of data as well.
Oh, wow.
Think about generating music 3D models, even entire virtual worlds, in seconds.
Okay, now you're just blowing my mind.
But it makes sense.
Yeah.
If they can crack the code for images, why not other forms of data?
Right.
This research could be the catalyst for a whole new era of AI creativity.
Yeah. Okay, but we've been talking about this paper for a while now. Are there any other key points we need to highlight before we move on?
There's one thing I found particularly interesting.
Okay.
You know how we've been talking about FID scores as a measure of image quality?
Yeah.
Where this new consistency model actually achieved FID scores that were much closer to those of state-of-the-art diffusion models, which is really remarkable.
Hold on, back up a second.
Yeah.
So you're saying this model, which is already blazingly fast, is also approaching the image quality of the top diffusion models.
It is.
That's a game changer.
It is, and it really highlights the potential of consistency models. They may not be quite there yet, but they're closing the gap quickly.
I'm starting to think we're witnessing a paradigm shift in AI image generation.
Yeah.
This research could rewrite the rulebook.
Yeah.
But before we get too carried away, let's take a closer look at how they actually achieved such impressive FID scores.
Okay.
There must be some specific details worth exploring.
Yeah, one key factor was their clever use of normalization layers within the model's architecture.
Normalization layers.
Yes.
Those sound familiar. Can you remind me what they are and why they're so important?
They essentially help prevent extreme values from throwing the model off balance.
So kind of like the Cauchy loss, but for the internal workings of the model.
Exactly. And they found that a specific type of normalization layer called non-scaling layer norm, or NSLN, worked particularly well for their model.
Okay, so NSLN, it's like the MVP of normalization layers.
Yeah.
Helping to boost those FID scores and push the quality closer to diffusion model territory.
That's a good way to put it. And this finding highlights how crucial it is to optimize every aspect of the model, from the last function to the architecture itself.
It's like fine-tuning a race car, making sure every component works together flawlessly to achieve maximum performance.
Yeah.
But you know, all this technical talk, I'm curious to hear your personal take on this research.
Yeah.
What aspect of this paper did you find most fascinating?
What struck me the most was how the researchers combined several different techniques,
Okay.
each addressing a specific challenge to achieve this breakthrough. It's a testament to the power of a holistic approach,
Okay.
of looking at the problem from multiple angles and finding creative solutions.
It's like they assembled a dream team of techniques, each playing a vital role in the overall success.
Right.
But you know, we've been deep in the technical weeds for a while now.
We have.
Let's zoom out for a moment and consider the broader implications of this research.
Okay.
What are the long-term possibilities?
Well, as we've touched upon, this research could lead to a future where high-quality AI image generation is accessible to everyone regardless of their technical skills.
Right.
It could democratize creativity and unlock a wave of innovation across various fields.
It's exciting and a little bit daunting all at the same time.
It is.
But hey, we're deep divers. We're always ready to explore uncharted waters.
Exactly.
Now, before we wrap up this fascinating deep dive, any final thoughts for our listeners? Any parting wisdom to leave them pondering?
I think the biggest takeaway is that we're living in a time of incredible technological advancement.
Yeah.
And research like this shows us that the boundaries of what's possible are constantly being pushed.
That's true.
Who knows what amazing breakthroughs await us just around the corner?
That's a perfect note to end on. The future of AI is full of possibilities, and we can't wait to see what unfolds. But before we sign off, I do want to remind everyone that you can find links to the paper visuals and all sorts of other goodies in the show notes.
Don't forget to check those out.
Until next time, keep those brain gears turning and happy deep diving. It's truly an exciting time to be following AI, and, you know, this research focusing on these consistency models is a perfect example of how the field is evolving at like breakneck speed.
Yeah.
Before we get too lost in the future, I kind of want to bring it back to the present for a sec. You know, sometimes we get so deep in the technical details that we forget to ask the simple question, like, so what?
It's a crucial question.
Yeah.
You know, we can marvel at the ingenuity of these techniques.
Right.
But we have to connect them back to the real world.
Right.
Like, what does this mean for you, the listener?
Right. We've talked about, the potential of these consistency models to be faster and nearly as good as diffusion models,
Yeah.
and, how these techniques might be applied to other types of data. But,
Right.
like, how does that translate into, like, tangible benefits?
So imagine a world where creating high-quality images is as easy as typing a text prompt.
Okay.
That's what this research is ultimately striving for,
Mm.
making AI image generation accessible to anyone, regardless of their technical expertise.
That's a powerful thought.
It is.
It's like putting a paintbrush in the hands of everyone,
Yeah, exactly.
allowing them to express their creativity visually, regardless of their artistic skills.
Democratizing art and design.
I love it.
Empowering individuals to create stunning visuals for personal projects or business ventures, or even just for fun.
And it goes beyond just the creative arts.
Yeah.
Think about fields like education, where teachers could use AI to generate custom visuals for their lessons,
Okay.
or in healthcare, where doctors could use AI to create personalized visualizations of medical data.
The possibilities are truly endless.
Endless, and this research is a major step towards realizing that potential.
It is.
I'm also thinking about the impact on industries that rely heavily on visual content.
Yeah.
Imagine advertising agencies creating entire ad campaigns with AI-generated images, or filmmakers
Yeah.
using AI to bring their fantastical visions to life.
Absolutely. It could completely transform the creative landscape.
Wow.
And it's not just about replacing human creativity, it's about augmenting it, providing new tools and possibilities for artists, designers, and creators of all kinds.
I love that perspective.
Yeah,
It's not about AI versus humans.
right.
It's about AI and humans working together
Exactly.
to achieve incredible things.
That's the future I'm excited about. And
Yeah.
this research really gives me hope that we're heading in the right direction.
It's inspiring, for sure. But it also raises some important questions, like, for example, what are the ethical implications
Hmm.
of making image creation so easy and accessible?
That's a big one. That's a critical consideration.
Yeah.
As with any powerful technology,
Mhm.
there's potential for misuse.
Yeah,
It's crucial that we develop ethical guidelines and safeguards as AI image generation becomes more widespread.
absolutely. We need to make sure that this technology is used responsibly and for the benefit of society as a whole. But, amidst all the excitement and all the potential, it's easy to forget that, this research is still
Oh, yeah.
in its early stages.
Very early.
There's still a lot of work to be done.
A lot of work.
While this paper demonstrates significant progress, consistency models aren't quite ready to dethrone diffusion models
Right.
just yet.
Not yet.
There are still challenges to overcome,
Yeah.
areas where they need to improve.
For example, they mentioned that their model isn't as good at capturing fine-grained details
Yeah.
as some of the best diffusion models.
Yeah. Yeah, and that highlights like an important area for future research.
It does.
How can we make these consistency models even better at generating those intricate details that make an image, truly realistic?
Yeah, it's a challenge, but I have a feeling that, those brilliant minds in the AI research community are already on it,
Oh, for sure.
pushing the boundaries even further.
It's like an endless frontier of discovery, and who knows what amazing breakthroughs await us just beyond the horizon. But
Yeah.
for now, I think we've explored this research paper to its fullest.
We've covered the key techniques, the impressive results, and the broader implications.
So as we wrap up this deep dive, any final thoughts you'd like to leave our listeners with?
Stay curious, keep exploring, and never stop learning. The world of AI is full of wonders, and who knows, maybe you'll be the one to make the next groundbreaking discovery.
That's a fantastic message. And to our amazing listeners, thank you for joining us on this deep dive into the world of consistency models.
Yes, thank you.
We hope you found it informative, insightful, and perhaps even a little bit inspiring.
We had a blast exploring this research with you.
And remember, you can find links to the paper visuals and all sorts of other goodies in the show notes.
Don't forget to check those out.
Until next time, keep those brain gears turning and happy deep diving.